All right, so we're going to get started here looking at this table of values that we're given at the very start. Now, thinking back to some of the tables that we saw in our card sort activity, this one is a function. We know that because each of the x values that are listed here are different. They're each only corresponding to one y value. And so there's actually something very special and unique about a table that not only this is a function, it's a special type of function that we call linear. And so what I want you to notice here is that the x values are increasing by 1. So to get from one x value to the next x value listed, we're adding 1. And we have a constant pattern of what's being added or what's changing in the y values. Notice how the y values are adding 2. So a characteristic of functions that are linear is that as x increases by 1, the y value is going to increase or it might decrease by the same number. And we call that number a constant rate of change. Every time x gets bigger by 1, y is getting bigger by 2. It could be subtraction, so it could be like every time x gets bigger by 1, the y values are like subtracting 3. As long as it's exactly the same pattern for the y values, you have something that is linear. Now, if we were to look at a counter example off to the side here of a different table, so let's say that we have the same x values, but our y values are 1, 4, 10, and 20. This still meets the definition for a function. If this was in our card sort, we could put it on the function side. But notice now that as x is getting bigger by 1, like first the y values add 3, then they add 6, then all of a sudden it's adding 10. So notice how it's not going up by the same number. Not a huge deal, it just means that it's not linear. So that would be a way for us to check or test if something is a linear relationship or not based on the table of values. All right, now one thing that this constant rate of change in the table is going to produce, it's going to produce a graph of a perfectly straight line. And we can actually see that constant rate of change from the table if we take a look here at the points on the graph. So if I were to actually just like highlight some points that I'm seeing, I'm noticing that every time x gets bigger by 1, the y values get bigger by 2. X gets bigger by 1 again, y gets bigger by 2 again. So because it's continually adding the same number, it's going to have that nice straight line, that constant rate of change. If they were going up by different numbers every time, it might look something like this. Like first it gets bigger by 3, and then it's getting bigger. Should make that not as steep. It's adding 3, and then it's getting bigger by 6, and then it's getting bigger by something else. It might look kind of more jagged. So that would be something that's not a straight line. It's little straight line segments, but it's kind of messy from start to finish. All right, so we are going to be talking a bit more about graphs today. And so I'm hoping that some of this is looking familiar, but I just want to review a few characteristics of this type of grid that we're looking at off to the side. We actually have a special name for that in math. That is called the coordinate plane. And the coordinate plane is made up of two things. So this first kind of darker line that's going in the horizontal direction, we have a name for that. We call that the x-axis. With our functions, we said that's where the inputs go, on the x-axis. And then we have another line here that's going in the vertical direction. And you'll notice how that one is labeled with a little y, and that's because this one is what we call the y-axis. And then if we plot a point on our coordinate plane, something like this, we can represent the location of that point with an ordered pair. So for example, the point that I ended up picking, I'm noticing that if I go up to where the x-axis is, it lines up with the x value of 6. And when we do our ordered pairs, our x value is always listed first. So we'd have a 6 in the first position, followed by a comma. And then if we look at how far down it goes, or if we look at where it is like vertically, going over to the y-axis, we can see that it's lining up with the y value of -4. So I would list that second. This is alphabetical. So if you think about like x comes before y in the alphabet, x is going to come before y when we're talking about plotting an ordered pair. All right, so we're going to continue doing some more work specifically with functions and graphs that are linear. And so when we have linear functions, one thing that we have to talk about is the slope. And so the slope is what describes the steepness of a line. If you think about different ways that straight lines can be drawn, you could have something really steep like this. That would have a large number for the slope. But it's also possible that you have something that's not very steep at all. So maybe it's still increasing, but it's just not as steep. That would have a lower number for the slope. And there's also different types of slopes. So if you take a look at these 4 pictures here, a positive slope is when our line is increasing from left to right. So if you look at the little man here that's walking on this line, when he's walking uphill from left to right, just like you read the page of a book, from left to right, that's going to be a slope that's positive. Now let's look at the next picture. So the next picture is now tilted, and now when we go from left to right, it's decreasing. It's getting lower. The little man going from left to right, this is when he's walking downhill. Now, it's also possible for us to have a slope of 0. So you could have a horizontal line where the little man going from left to right, he's just walking right on top of that horizontal flat ground. There's no hill at all. And then it's also possible to have an undefined slope. And look, the little guy can't walk at all. That's if it's a vertical line. Oh, he's falling. He's not even able to stay on it. So that's when our slope's undefined. All right, so something that's going to help us to specifically define the slope, to define the steepness of our lines, is the slope formula. And this has to do with the picture that's written off to the side. I'm actually first going to show you the formula, though, just in words. So the way that we determine the steepness is we're looking at the ratio of the vertical change over the horizontal change. And so depending on how those numbers compare, so that's going from one point to another, that could either result in a really steep line or something that's not as steep. And so when you take a look here at the picture, we're just going to say here, all right, suppose that we have 2 points plotted that are on the line. The first point down here, the x value, we're just going to call it x1. It just represents some number. The y value over here, we're going to call that y1. And then that's connected with another point where the x value is x2 and the y value is y2. So when we're talking about this part at the start, the vertical change, the name we have for that, kind of a shorter name, is we call it the rise. Like how far is it rising vertically from one point to the next? And if we wanted to calculate that distance here, the rise, all we would need to do is subtract the 2 y values. If you think about if we had actual numbers here, let's say that the value of y2 was like 10 and let's say maybe that y1 was 4. So if we wanted to know the distance between them, we could just do 10 minus 4. So that'll tell us that, oh, it's 6 spaces in the vertical direction. So to get a little bit more technical with our formula, instead of writing out the word slope every time, we're actually going to use a little lowercase m. So m is always going to represent slope. And we're going to put in some notation now for getting that vertical change. So to figure out that rise distance, we're just going to subtract. We're going to do y2 minus y1, meaning we'll just take like the second y value, like the higher y value, and subtract the lower one. And I'm going to continue to use my colors here. So everything here in yellow, those pieces go together. Let's take a look now at the horizontal change. So that's going to be our denominator. Now we also have a special name for the horizontal distance between the 2 points. We call that the run. And notice that that is based down here on the 2x values. It's just going to be subtracting x2 and x1. Again, if we put numbers in here, like let's say that x2 was 8 and maybe x1 was at the number 3, if we wanted to find the distance between them, we would do 8 minus 3. So we can see, all right, there's 5 spaces across for the run. Putting it back into our symbols, that's going to be x2 minus x1. Now, the last thing that's really important with this formula, well, first of all, when we get our values, our numbers, it's either going to simplify down to a final answer. It might be a fraction, so plenty of times our slope, we just keep it as a fraction. We don't typically report slope out as a decimal. The fraction is really helpful because it tells us, like, the numerator is the vertical change, the denominator is the horizontal change. But what's important about the way this formula is set up is that the order of the subtraction is consistent. So notice how in this first position, these 2 points go together. So x2 and y2, that was from the same point. In the second position here, those 2 numbers are also from the same point. So that was from x1, y1. So this is typically how we write this out, as y2 minus y1 over x2 minus x1. But I think it's also useful for you to know that you could do it the other way around as long as you keep the order of your subtraction consistent with what you do on the top to what you do on the bottom. So look at this. You could actually do y1 minus y2 as long as on the bottom you do x1 minus x2. So no worries about like, well, how do I know which one goes first? It doesn't actually matter yet. Just make sure that like whichever point value you choose to go first on the top, that corresponding x value is going first on the bottom. Okay. So we talked about what is linear. We talked a lot about slope. We're going to get into some practice now. So let's go ahead and turn over to the next side of your paper. And so we're going to try out this formula. So we're going to determine the slope of the line that's containing each pair of points. And the slope formula that we just talked about is how we're going to do that. So you may find it helpful to actually rewrite out the formula, since we are now working on a new page. And it doesn't matter how you define these to be. I typically would have the first point listed as x1, y1, and the second point listed as x2, y2. All right, so let's just take a look at this first one together. So if I were to plug the numbers in, I'm going to notice here that y2, I've defined that to be 7. I'm going to start with the 7. Bring over the subtraction sign because that's part of our formula. And that's going to be subtracting y1. So I defined y1 to be 6. I'm going to put that in that position. And if we actually want to keep going all the way, we can simplify the numerator. So 7 minus 6 is 1. That's going to be the rise. That's going to be the vertical change between the points. This is how we can find that without having to graph them. Let's take a look here at the denominator part. So notice that the order of our subtraction here is staying the same. So we're starting with x2, and I define that to be 1. So I'm going to put a 1 here in this position. We're going to bring over our subtraction sign again. And then we're subtracting x1, so we define that here to be 5. And this is going to go into the negatives. That's okay. 1 minus 5 is negative 4. Now, a final way to report out our answer here, if you think about doing positive 1 divided by negative 4, a positive divided by a negative is negative. And so we could actually just put the negative out in front of the whole thing, not specifically attached to the denominator part. It can just be in front of the whole number, is typically how we'll see it. So our final answer here will just be that we have a slope of negative 1/4. If we were to graph it, because the slope is negative, that just means it's going to be decreasing from left to right. The little man is going to be going downhill with that negative slope. All right, so go ahead and try part B, C, and D. So I have the next 3 here for you to try on your own. We're going to practice putting it in the formula, and we're just going to see what happens. All right, so let's come back and talk and just see what happened here with our numbers. So we had a few interesting scenarios. So here in part B, we should end up with a slope of 5/3. It's okay to go ahead and leave this as graphic. So we had that subtracting a negative here on the top. So just be careful of that. That can be a really easy thing to accidentally forget. The negative sign is part of the formula. So like in this case, 3 minus negative 2, it really just turns into 3 plus 2. So that's how we get a 5. Now because this one is a positive slope, if we were to go and make the graph, positive slope is increasing from left to right. So the little man now is going to be running uphill. All right, let's take a look here at part C. So something interesting happens because we actually have the same y value. So if the y values are the same, in this case they're both 4, well, when we subtract them, the vertical change is 0. It's not changing in the vertical direction at all. And so we have a 0 on the numerator. Now our denominator, that's really 8 plus 3, so we get 11. But here's the thing, this fraction means 0 divided by 11. And you can even check that in your calculator. 0 divided by anything is equal to 0. So our final answer on this one here, that's mathematically what it would look like to get a 0 slope. Now 0 slope is when we have a horizontal line passing through our 2 points. And if you think about like what this would actually look like on the graph, like the point negative 3, 4 might be that first one, and then 8, 4 is the second one. Like it makes sense that it's horizontal because they have the same y value. Like it's going to be in the same y position. So that 0 slope, that's when our little guy is walking or running just across like flat land. All right, and then let's see here what happened in the last one. So we get negative 7 divided by 0. Are we allowed to divide by 0? You've probably heard all throughout your schooling, this is something that we just simply do not do. We can't do it. In fact, if you try to type it in your calculator, you're going to get an error. The calculator is saying, no, we cannot do this. And so anytime you are dividing by 0, this is actually, it's not equal to 0. This is the one that we're going to write out the word. It's undefined. We can't do it. It's not possible. And so if we think about the undefined slope, that was this picture here. That is a vertical line. It's not good for our little friend because he cannot stand on this. So he is falling. He's falling off that line. And if you think about the vertical line here and the actual points that they gave us, so they gave us the point 2.6, that might be up here. And then they gave us the point 2, -1, which might be down there. So look at this. They have the same x value of 2, just different y values. So it makes sense that it's going to be a vertical line because it's not moving at all in the x direction. The x value is the same. Here's a little bonus question for part D. Is this representing a function? I want you to talk at your tables and tell them what you think and why. Correct. This one is not a function. The same x value of 2, it's going to it's going to 2 different y values. Also on the graph, it doesn't pass the vertical line test. It is a vertical line. If you drew a vertical line on top of that vertical line, technically you're going to cross through an infinite number of times. All right, awesome job. So slope is one important aspect of linear functions when we think about graphing, but the other piece of this is the y-intercept. And the definition for the y-intercept is that this is the point where the line crosses the y-axis. And I'm not going to make a perfectly detailed graph here, but I did pick a y-intercept of 5. So I plotted a point on the y-axis where the 5 would be. And then I just drew a line through. That's a line that has a positive slope, by the way. And what I want you to notice is that when we list out the ordered pair, if we want to figure out the x value of a point that's on top of the y-axis, the x value is actually 0. And that makes sense because the x-axis is kind of like a number line. We've got negative values on the left, we've got positive values on the right. Well, what's smack in the middle separating the negatives from the positives? It's the value of 0. And so one little note that we're going to put down, this is super important to know for the y-intercept, is that x always equals 0 at that point. So now we are going to put all of the pieces together to get slope-intercept form. So the formula for this is y equals m times x. Usually we just say mx plus b. Now the m that's multiplied in front of the x, we saw that before. Remember, m is the slope. And then the b, that is the number here at the end, that is the y-intercept. Now, if you see a number that looks like it's being added on the end, that just means your y-intercept is a positive value. So it's going to cross the y-axis somewhere up here where the positives are. If it looks like a number is being subtracted from the end, that just means that your y-intercept is negative. So it's going to cross somewhere down here where the negatives are. The equation for a linear function is defined by the slope and the y-intercept. All right, we're going to do a little bit of practice now with this. So let's turn over to the back side. And here we're going to complete this table. So you're going to go ahead and look at the equations that are given. You're going to identify the slope and also write the y-intercept as an ordered pair. And then you're going to go the other direction. So see if you can do the last two, where it gives you the slope and the y-intercept. You have to turn it back into the equation. We'll take a few minutes here to fill in that. All right, so the number that we see out in front of our x is always going to be our slope. So first we have a slope of 1/2. The number at the end is our y-intercept. So check to make sure that you have these written as ordered pairs. Notice how the x value is 0 for all the ordered pairs. That minus sign in front of the 5 just means the y-intercept is -5. One thing that was a little interesting on the last one is that we had a y-intercept of 0. And so technically it would be y equals 5/2 x plus 0. You could write it that way. Another way that you can write this is just y equals 5/2 x. So if you don't see a number on the end, we're just going to remember and assume that it's really an invisible plus 0 on the end, but that's what's going on if you ever don't see that number. The other thing that is really helpful to know is that although it is then in this format for these 4 examples, the slope part multiplied by x is not always listed first. So slope is not just the first number that we see, it's the number attached to the x. So let's look at an example here. In this second row, another way that we could have written that is we could have put the positive 2 in front, and we could have put the minus 3x behind it. So if I gave you that, our slope is still negative 3, even though it's listed second. Our y-intercept is still 2, even though it's listed first. It just has to do with what number is attached to the x or not. All right, let's take a look now at the next problem. So this is actually a different type of format. I'm going to have you write this off to the side. The way that it's given to us is called standard form. And standard form looks like this. The x and the y are together on the same side, and the number in front of x, we'll just call that a, the number in front of y, we'll just call that b, so those just represent numbers. C represents like a different number on the other side. So that's kind of what we have here. Eventually, in order for us to graph, we need to be able to identify the slope and the y-intercept. Those are the two pieces that are going to help us to graph. And so if we have something that's in a different form, we will have to do a step at the very start to get it in slope-intercept form so that, for example, we could graph it. And so because slope-intercept form, so like our final answer here, needs to be in y equals mx plus b format, notice all that's happening here is we just need to get the y all by itself. And so really, all we're doing in this problem is we are rearranging things. We're really just solving for y. We actually did some problems like this back in Chapter 1. Those literal equations, those formula problems where we're just rearranging things to get a letter by itself. Part of why we need to know how to do that is right here. So if we want to get y by itself, we could start by subtracting the 6x from both sides. So all we're left with here is 3y on the left. Now, you have two options for how you want to write the other side. The order doesn't matter. So you could write 15 minus 6x, or you can write negative 6x plus 15. I'm putting a plus sign in front of the 15 because I can see that the 15 is positive, so that's just a way to indicate that it's positive. I like this version that I wrote because it lines up with y equals mx plus b. It doesn't have to, but I kind of like it when it does. Now notice the only thing we need to do here then to get the y by itself is we have to get rid of that 3 that's being multiplied in front. So we are going to divide everything on both sides by 3. And here's what that looks like. So let me show you. Instead of writing this on the other side, an equivalent way of doing that is to divide each part by 3, like individually. So that's just a different way of saying the same thing. And this is going to work out really nicely here. So the 3's are just going to cancel there on the left side. So sure enough, we have y by itself. Negative 6 divided by 3 is negative 2. We've got negative 2x. Bring down the plus sign. 15 divided by 3 is 5. Now, sometimes our numbers do not divide perfectly here. That's okay. If it doesn't divide perfectly, Leave it as a fraction. Fractions are fine. Now a little extension on this one. Off to the side here, I want you to fill in and identify what is the slope and what is the y-intercept. So go ahead and fill in those two blanks. All right, so we should get a slope of -2, and then we always write the y-intercept as an ordered pair. So just double check there. If you just wrote 5, that's correct. It's 5, but as an ordered pair, the position on the graph, it's 0, 5. All right, so we have now made it to the final piece of our lesson today. This is where everything is now going to come together to ultimately allow us to graph lines that are in the slope-intercept form. So there's really 3 steps here that we're going to do. Step 1, we already know. We're going to identify the slope and the y-intercept. We've had a lot of practice with that now. Step 2 is to start by plotting the y-intercept. So that's your starting point on the graph. And then step 3 is to use our slope. We're going to think about rise over run to get the next points on the line. So let's look at an example. In this first one here, I'm noticing that the slope is 2/3 and the y-intercept is 0, 4. So I'm going to start by identifying. And then we're going to go ahead and plot the y-intercept. So I'm just going to plot a point right here, passing through the y-axis at 4. And then here's how we're going to think about the fraction that we have for slope. So remember that the numerator part is representing the rise. That's the vertical change. So how far am I going vertically to get from one point to the next? And then the denominator part is the run. How far am I going over horizontally? Now, before I start to count out the number of spaces, so up 2 spaces over 3, I need to know what direction this is going. And so that means we need to see if it's a positive slope or if it's a negative slope. So what I like to do before I even put my line on there, when I identify slope, I'm either going to put a plus sign next to it or a minus sign so I can remember if it's positive or negative. And then I'm just going to draw a little sketch. It's not the full graph, but I'm just going to draw a little line knowing what direction that's supposed to go. So if the slope is positive, it's increasing as we go from left to right. Okay, so here's why that's helpful. So from the y-intercept, the rise is 2, so we're going to go up 2 spaces, up to the y value of 6. The run is 3. We're going to go over 3 spaces to the right. And that's going to make it go the direction that it's supposed to go. Notice that if we would have gone over 3 spaces to the left, now we have a negative slope, which is not what we want here. Technically, you only need 2 points to graph a straight line. So you could grab a ruler or a straight edge and you're done. If you want to get some more points, you could just continue the pattern. That's what I like to do. I like to do a few more points. So from this one where I ended, I'm just going to do it again. Up 2 over 3, up 2 over 3. I'm just going to go as far as I can go. If you want to get some points going backward, you could do that pattern in the opposite direction. So you could go down 2, left 3. That's the opposite of up 2, right 3, right? They're just opposite, but it's going to create points that are still in the same line. All right. You can grab a ruler if you have one. If not, we'll just do our best to just kind of draw a line through. That's what I did. Mine's not perfect, but that's our final answer for our graph. All right. I would like you to go ahead and try the next one. All right, so let's double check your graph here. So this one is now a slope of 1/2. I made a note here that it's positive. I made a little reminder so I know what direction it goes. This one now has a y-intercept of -6. So the only difference is that instead of start down here at -6, it's still this positive increasing slope direction. So from this starting point, the rise I'm going to run is 1 over 2. So we're going to go up 1, 2 to the right, up 1, 2 to the right, up 1, 2 to the right. How that works. So here's a sample question from our homework for tonight. Number 8, 9, 10, 11, and 12 are all graphs. Those are the ones that you want to use graph paper here when you're doing your written work. So here it's giving us an equation. So here we have like y equals 3x plus 1. If you click this button here to enlarge the graph, that's what I would suggest. Now you have some different types of like buttons to click. And so the one that you want to choose is this one right here. That's the line tool. And all you need are 2 points for your line. So I remember that this one had a y-intercept of 1. So I'm going to find that point. I'm going to click down. And then it had a slope of 3. So that actually means it's going to go up 3 over 1. Because if I were to write that as a fraction, 3 is the same as 3 over 1. Once you click that second point, the line is drawn. We're going to hit save, and we're going to go down to check our answer. We're not just doing the graphs on the computer. You are doing it first on paper. You're getting credit for that for your written work, because when you do this on the test, you're not doing the test on the computer. You're doing your test on paper. This is just going to allow you to check it just to make sure that you drew your graph correctly. All right, let's go ahead and turn over to the back. All right, now the difference in the next two equations that we have here are that now our slopes are negative. So we're just going to be careful with that and see how it's going to look a little bit different. So in this first one here, notice that our slope is -2. I'm going to write that as a fraction right away. So that's the same thing as -2 over 1. We need to have that numerator and denominator so we know how to count the steps when we do the rise over the run. All right, and this one has a y-intercept of 3. I'm going to make a note here that since our slope is negative, we need to have it be going the opposite direction now. That little man is going to be going downhill. All right, so when we go ahead and do our graph, we're going to start at the y-intercept of 3. Now we're going to go up 2 spaces, but now we have to go over 1 to the left. Up 2 over to the left 1. If we continue that pattern this way, all the way down to the edge, notice that when we connect it, it's just one continuous line here. The little man is walking downhill, and that's because we had a negative slope. All right, let's take a minute here to go ahead and try the next one. All right, so a few slight differences on this one. So this one has a y-intercept of +1. So we're going to be starting here. The slope is -3 over 1. So it's still going to look like a negative slope. This time though, we're going up 3 spaces, 1, 2, 3. We're going over 1 space to the left. Up 3 over 1, and so on. Notice how this one is a little bit steeper than the other one that we did. So that's because when we go up 3 spaces over 1, it's a little steeper than only going up 2 spaces over 1. All right, so that's what we're going to be careful of. If you don't see a denominator, it's 1. If it's a negative slope, we need to make sure that it's going the other direction. All right, now something interesting that's happening in the last set is that we don't see a y-intercept on the end. So like for this first one, when it's just y equals 3x, what's a y-intercept? 0. Great job. So remember that it's really supposed to be a +0. So where that's going to be on the graph, well, it's going to be like right in the middle of the x-axis and the y-axis. This little point here has a special name. It's called the origin. That's the point 0, 0. So that's what we're going to start with if your y-intercept is 0. Now, this one has a slope of 3 over 1. It's positive slope, so it's going to look like this. From our starting point, we're going to go up 3 over 1 to the right because it is a positive slope, up 3 over 1, and so on. And we've got our graph there. All right, a couple of interesting things on the last one. So this one also has a y-intercept of 0, so same starting point. Let's think about the slope here. So we don't actually see a number in front of the x. Like all we see is a negative. So that means that it's really -1. So this is another one of those invisible math pieces. A negative in front is really a -1. And we were missing the denominator. So that would be 1 as well. The negative sign is just telling us that it's going this direction. And this is a fun slope to do because it perfectly follows our grid. In this case, we're going up 1 space, over 1 space. We have to go over to the left to make it a negative slope. Up 1, over 1, up 1, over 1. And it is actually like perfectly cutting through the diagonal for all of our low squares. All right, so we're going to finish up here at the very bottom of your page. You're now going to see some graphs that are already done, and we're going to see here if you can work backwards. So you're going to go ahead and write the equation for each graph in slope-intercept form. So let's take a few minutes here to go ahead and try those 3 graphs at the end. All right, so first what we should have here, it's y equals 2x minus 1. So notice how it's got a y-intercept here at -1. And to get from one point to the next, we're going up 2 over 1. So it's going to be 2 over 1, which is really just the same thing as 2. This is a positive slope because of the direction that it's going. So it's just going to be a positive 2 in front of the x. All right, the next one is a negative slope. So notice how it's going the other direction. So this direction means a slope that's negative. So put a negative sign. To get from one point to the next here, we're going up 1 over 3. So it's 1/3. We'll make sure we have that negative in front. And then it's plus 2 at the end because our y-intercept is positive 2. That last one was interesting. So it's not increasing or decreasing. So remember that that's when the slope is 0. And so it's really like putting a 0 in front of the x. The only thing we have is the y-intercept. It's crossing through the y-axis at the point 0, 4, so I put a plus 4 at the end. Now here's a fun fact on this one. You don't have to write 0x in front. 0 times anything is 0, so 0 times x is 0. You could shorten this and just write y equals 4. So it turns out if you have y equal to a number, it's just a horizontal line that passes through that number.